Okay, so this is your Quiz 6 study guide for Unit 3. And in this quiz, you're going to have to describe the transformations and then graph the radical functions. So before we start, let's kind of review how we can find transformations just by looking at a radical function. So if we have f of x equals a radical function, the possible transformations could be a, and then we would have a square root. We could have b, we could have h, or we can have k. Now, each of these variables tell you a transformation. So if there is a number where the variable a is, that means that there would be a vertical stretch or shrink. To know if it's a stretch, a needs to be greater than 1, and to know if it's a shrink, a needs to be in between 0 and 1. Our variable b is a horizontal stretch or shrink. It could also be said as expanded or compressed. To know if it's a stretch or if it's expanded, it's actually the opposite of what a vertical stretch or shrink is. So for a stretch, it needs to be in between 0 and 1, and for it to be a shrink, it needs to be greater than 1. Our variable h tells us if it is a horizontal shift, and then it tells us if it goes left or right. To know if it goes left, the sign under the radical needs to be a positive, and then for it to go right, it needs to be a negative. And then the last variable, k, is a vertical shift. And vertical shifts tell us if they go up or down. To know if it goes up, the sign needs to be positive, and to know if it goes down, the sign needs to be negative. Okay, looking at problem 1, the directions say to describe the transformations to square root of x shown in the following radical functions. So the first thing we're going to do is to point out everything that we see in this radical function. I see a negative 4 out in front, a negative inside the square root, and a plus 8 at the end. So, the negative 4 out in front, this is technically 2 transformations, but what we just said before is that the a variable, which is what this is a vertical stretch or shrink. Since 4 is greater than 1, we know that this would be a stretch. The negative actually tells us that this is a reflection, and the reflection is over the x-axis. The negative inside the radical is also a reflection, but this reflection is over the y-axis. And then the plus a out in front, which could also be seen as our variable k, tells us that it is a vertical shift, and because it's positive, we are going to go up 8. Okay, so for problem 2, we have the function g of x equals negative 4 square root of x plus 5 minus 1. So let's point out what we see. We see a negative sign in the front, and then a 4. We see a plus 5 that's under the square root, and we see a minus 1. Just like last problem, if we see a negative out in front, that means that it is a reflection over the x-axis. We also see a 4 out in front, and because 4 is greater than 1, this is a vertical stretch. Under the square root sign, we see a plus 5. And if we remember that with horizontal shifts, we actually kind of flip the sign. So this is x plus 5. That means that we're actually going to go left 5. And then on the outside, at the end of the function, we have a minus 1, which means that we go down 1. And those are this function's transformations. The next couple questions asks us to graph the following radical functions using transformations. So, number 1, our function is 2 radical 3x minus 9. So, before we start graphing, we always write down the first points that we know for sure. What we know for sure is the parent function is radical x. So that means if we do a little t-chart of x and y, when we plug in 0 to this parent function, we get 0. When we plug in 1, we get 1. When we plug in 4, square root of 4 is 2. And then when we plug in 9, we get 3. So we can start with those. Okay, so to apply the transformations, we actually have to do it in a certain order. So the first thing that we're going to want to look at is our negative 9 that's under the radical. So this means that you are actually adding 9 to your x value. So then we can write our new chart. That's a wonky line. Alright, now our x's are what changes. So we have 0 plus 9 is 9, 1 plus 9 is 10, 4 plus 9 is 13, and 9 plus 9 is 18. And then our y's all stay the same. The next transformation we're going to look at is our 2. So our 2 out in front is the same as the variable a, and our variable a told us that it could be a vertical shrink or stretch. Because 2 is greater than 1, we know it's a stretch. And so what we do here is we multiply our y's by 2. So we're going to keep our x's and take our y's, multiply them by 2. So 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4, and 3 times 2 is 6. And then the last transformation we have to do is this 3x that's under the radical. I'm going to put it down here. So this actually tells us to divide our x's by 3. So we have our x equals 9. 9 divided by 3 is 3. 10 divided by 3 is just 10 over 3. Keep that the same. 13 divided by 3 again is just 13 over 3. And then 18 divided by 3 is 6. And then we can keep our y's the same. Okay, so now we can actually graph this function. Now that this is our final points, because we applied all of our transformations, we can now graph it. So we have point 3, 0. We have point 10 divided by 3, which is approximately 3.3-ish. So we're going to have kind of around here. We have 13 divided by 3, which is 4.3-ish. So we're going to put that there. And then we have 6, 6. And then that is what our radical function would look like. Number 2 is the function g of x equals negative 4 radical x plus 5 minus 1. So we start with the same parent function, and we plug in those points like that. And then we can start looking at the transformations that we see. So let's look on the outside first. We see a negative 4. So this means that it is a reflection over the x-axis as well as a vertical stretch, because 4 is greater than 1. So to find our points here, we can just multiply negative 4 to our y values. So this would then change it to keeping our x values, and our y values would be 0, negative 4, negative 8, and negative 12. Then we can look at this plus 5 that's under the radical. This, we know, is a horizontal shift left or right. So to find this, we would subtract 5 from our x values. So 0 minus 5, negative 5, negative 4, negative 1, and 4. And then we would keep our y values. And then the last one would be our minus 1 at the end, which we know is a vertical shift down 1. So we can just subtract 1 from our y values and keep our x values the same. Like that. And then we can just graph this. So we got negative 5, negative 1. We got negative 4, negative 5. Negative 1, negative 9. And 4, negative 13. That's all the way down here. And then that would be our radical function. Our function for number 3 is under the radical is 2x plus 8 and then plus 3. So let's start just by putting down our parent function points. It's always the first step. Alright, then we gotta pay attention to our transformations and what order they go in. So we have a 2x plus 8 under the radical. It's extremely important that you go in the right order, otherwise your transformations would be incorrect and your graph would be incorrect. So it's either 2x or the 8 that goes first. And from what we know from our order of operations is that we want to do the plus 8 first, which actually means that we're subtracting 8. I'm also going to start doing kind of 2 at once, because the reason I'm allowed to do that is because there's 2 x's and 1 y transformation. So I can just do the y transformation now because it's not going to affect when and where I do it, since there is only 1. So we have a plus 3 at the end. That means we're going to go up 3, which means we're going to add 3 to our y values. So our new table, if we subtract 8 from every x value, we get those values, and then if we add 3 to every y value, we get that. The next transformation is our 2x right here. So this 2 in front of the x means that it is horizontally compressed. And so to change our x values, we need to divide all of them by 2. So if we keep all of our y, and then we divide by 2 for all our x values, we get those values, and then we are able to graph that. So let's plot in our points. We got -4, 3. -7 over 2 is about -3.5. And then up 4. And then we have -2, 5. And we have 1/2, 6. So then that would be our graphed radical function. And our final problem, number 4, is g of x equals 3 radical -x minus 2 minus 6. So once again, we're starting with our parent function of just radical x, and we're plugging in the points that we know. And then we want to look at our transformations. So we have every type of transformation here, basically. So this is where our order of operations is extremely important. The first thing we're going to want to do is our horizontal shift. That means we're going to look at this -2 that's under the radical. So that actually means that we're going to add 2 to all of our x values. And then again, I'm going to combine and also look at the next order of operations is a stretch or a shrink. And I'm going to say, look at my 3 out in front and say they can multiply my y values by 3. Alright, so we're going to have 2, 3, 6, and 11. And then for our y values, we're going to have 0, 3, 6, and 9. Alright, and then our next transformation that we can look at is a reflection. And we see this negative right here. We can say that our x values are going to be divided by -1. And then I'm also, just in the same step, going to look at my -6 because it's not going to affect my reflection at all because it's on the y values. And I can say that I can subtract 6 from all of the y values. Alright, so these are all going to change negative. And then we're going to subtract 6. And then we can plot our points. We have -2, -6. We have -3, -3. -6, 0. And -11, 3. Right there. So that is our graph radical function.